In today's industrial automation, the 4 to 20 milliamp transmitters are used in a wide range of processes for monitoring many parameters such as temperature. By watching this video, you, as a technician or instrument engineer, will learn about the wiring configurations that you might run into with 2, 3, and 4-wire transmitters along with their pros and cons. Also, you will learn how to connect these 4 to 20 milliamp transmitters to a programmable logic controller or PLC. Okay, let's start with a brief definition of a transmitter. A transmitter is a device that senses the real-world signal from a sensor and converts it into the control signal, which represents the variable being measured. A broad range of voltage or current output signals is provided on transmitters. So far, the most frequent analog signal used in industrial applications is 4 to 20 milliamps. Why, you may ask? That's a topic for another video. This kind of transmitter is designed in a way that at calibrated zero input, you will get 4 milliamps, and at calibrated full-scale input signal, you will get 20 milliamps. Now that you got familiar with 4 to 20 milliamp transmitters, it's time to discuss how to connect these transmitters to the PLC. You should know that several types of 4 to 20 milliamp transmitters wiring exist, and they can be divided into 3 categories: 2-wire, 3-wire, and 4-wire configurations. These current loops have 3 things in common: a transmitter, a power supply, and a receiving device such as a PLC. Let's start with the wiring configuration of a 2-wire transmitter. A low-voltage DC power supply, usually 24 volts, is used to power the 2-wire transmitter in this current loop. But how is that possible? The 2-wire transmitter steals its power from the 4 to 20 milliamps current running through the loop. The transmitter uses some of that power to operate itself. It's a fantastic trick, don't you think? One important thing to mention here is that in the 2-wire current loop, it doesn't matter in what order you put the power supply, transmitter, and PLC. They can be in any order, but they must always be in the correct polarity, so we should trace the current through this loop. The current goes from the positive side of the power supply to the positive side of the transmitter. Here is where it gets a little tricky, is from there, the current goes from the negative side of the transmitter to the positive side of the PLC analog inputs. Then it goes back out of the negative side of the PLC analog input to the negative side of the power supply, and that will make our current loop. It's time to mention the 2-wire current loop pros and cons. The key advantages of this design are: it consumes less power, it makes installation easier, it has low maintenance, and it is low cost. On the other hand, the main disadvantages of this design are: it has the lowest measurement accuracy among other wiring configurations, and if the fault condition happens, this configuration continues drawing some current, so we can't set the transmitter fault signal at 0 milliamps. Our next step after the 2-wire loop-powered transmitter is to check the wiring configuration of a 3-wire transmitter. The power supply used in this current loop cannot be an AC power supply. It must be a direct current, usually 24 volts DC. From the positive side of the power supply, we bring 24 volts to power up the transmitter. Then the transmitter generates its desired signal current, which is the 4 to 20 milliamp signal going to the analog input of the PLC. And as the common side of the transmitter and the common side of the PLC analog input are the same connection, this is the return path of the 4 to 20 milliamp signal. Let's consider the pros and cons of the 3-wire current loop. The advantages of this type of configuration are: the transmitter requires only 3 cable cores, and it uses a shared power supply for both the transmitter and the PLC. And the disadvantages of this type of configuration are: it does not feature electrical isolation, since the common side of the power supply and the process signal return share the same wire. Due to the electrical interference that may be transmitted along the signal line, the PLC will generate a false alarm, and at first, it may be challenging to wire for technicians. After understanding the 3-wire current loop, we finally get to how to do a wiring configuration of a 4-wire transmitter. A 4-wire transmitter has 2 pairs of wires, one pair for the power supply and the other separate pair for the control signal. This type of transmitter is often externally powered, and because of this, the power supply can be alternating current AC or direct current DC. So just by bringing the power supply voltage to the 4-wire transmitter, we make it operational. From here, the connection is pretty straightforward. The positive polarity of the transmitter milliamp signal connects to the positive polarity of the PLC analog input. Also, the negative side of the transmitter goes to the negative side of the PLC analog input. As you can see, it's a parallel connection and not a series circuit. And through these separate cable cores, the transmitter brings the 4 to 20 milliamp signal right over to the PLC analog input with a return path. Finally, it is better to look at the pros and cons of the 4-wire current loop. This wiring configuration type has the following advantages. Isolation is integrated into the system, which means the return process signal wire is not connected to the power supply ground. In other words, we can say the power isolation from the PLC analog input, eliminating the electrical interference problem over the 4 to 20 milliamp signal line, thus reducing the risk of a spurious alarm being received. And it's easier to understand the wiring for technicians. To complete this video, we need to mention the disadvantages of this wiring configuration as well, which are the following. It is not suitable for use in hazardous areas because if the 4-wire transmitter is powered by high power supply voltage, and meanwhile the industrial site includes flammable or combustible vapors, fumes or dust, we could face ignition under certain conditions. And it is costly due to more wiring requirements and the need for a separate power supply for the transmitter. Yoo-hoo! Congratulations! Now you are officially an expert in wiring configurations of 2-wire, 3-wire, and 4-wire transmitters. If you have a unique experience configuring these transmitters, please share it with us in the comment section. Also, if you found this video helpful, please encourage us by liking the video, subscribing to our channel, and pressing the bell icon so you can get notifications whenever we publish new out of the oven videos. This way, you keep motivating us to produce more informative videos.